Welcome back. This is the third lesson recording for IM1, November 20th, 2020. So we've done one dividing fractions problem where we actually know the answer, but we use the method of flipping the second fraction and changing divide sign to multiplication. So we've done that and got the same answer. Okay. But what about this problem, which is a little bit less intuitive? Like 4 divided by half. While 10 divided by 2 is asking you how many, if you are trying to divide 10 into groups of 2, how many groups would you have? So we're trying to divide 4 into groups of half. How many groups would you have? Well, because it's less intuitive, let's see if we can use our method here. So 4 is same as 4 over 1 and divide by half. Divide by half, we need to flip the second fraction, okay? So that's going to be 2 over 1, and then change the divide sign to multiply, and then multiply top with top and bottom with bottom, and that becomes 4 times 2 is 8, and 1 times 1 is 1. So 8 over 1 is really same as 8. So this tells me if you are trying to divide 4 into groups of halves, you'll get 8 groups. So let's try to do this problem again. We would do 4 over 3. The first fraction remains the same. The second fraction gets flipped. So that becomes 2 over 3. And the divide sign changes to multiply. Okay. And then you multiply top with top, bottom with bottom. That becomes 4 times 2 is 8. 3 times 3 is 9. Okay. What about this one? 2 is really same as 2 over 1. Okay, so this becomes 2 over 1 multiplied by, flip the second fraction, and that's 100 over 1. Top with top, bottom with bottom, that becomes 2 times 100 is 200. Divide by 1. 200 divided by 1 is just 200. That's our final answer. What about this? Mixed fractions. Remember with mixed fraction, multiplication, division, you need to convert this into improper fraction. How do I do that? I use my mad face method where you multiply and then add. There's my mad face. So 5 times 3 is 15 plus 1 is 16 and denominator stays the same. So that's 16 over 5 divided by 2 over 2. So instead, I am going to flip the second fraction. Okay, so 16 over 5 multiplied by oops. So that's 16 divided by 5. And we are going to flip the second fraction and change the division sign to multiplication. Oops, I meant this is meant to be 2 over 3. Sorry. 2 over 3. So then in this case, this becomes 3 over 2. 16 times 3 is 48. And 5 times 2 is 10. Now, is this the simplest fraction? Well, first thing is I want to simplify the fraction by dividing top and bottom by some number. They are both even. That means I can divide top and bottom by 2. That makes it smaller. So it's far easier to see how big the number is. And then from here, I can simplify this further into a mixed fraction because when you're answering, it's better to give a mixed fraction rather than 24 over 5. Why is that? Let me explain in a minute. So how many 5s go into 24? Well, 4 times 5 is 20. So, and then 4 times 5 is 20. So 24, take away 20 is going to be you're left with 4 over 5. Okay. The reason you want to convert any answers into mixed fraction is when you look at 24 over 5 or 4 and 4/5, can you kind of visualize how big the number is? This tells me 4 whole pizzas and 4 pieces of pizza out of the, you know, 5 divided pizza. This one, 24 over 5, that seems a little bit more abstract in my mind as to how big that number is. So you can really visualize this number. This tells me it's little less than 5. Okay? All right, then let's do this problem. 1/5 divided by 3. This is same as 3 over 1. That means this is same as 1/5 multiplied by 1/3. Flip the second fraction. And top with top, bottom with bottom, that's 1/15. Okay? Okay, let's finally tackle adding and subtracting fractions. Unlike regular adding and subtraction, adding and subtracting fractions is probably the most difficult out of all the fraction operations. That's because sometimes the fractions, the denominators are not the same. Remember, the number at the bottom are called denominator. And so if I'm trying to add this 1/3, if I was to represent this as a pizza, I have 1/3 of a pizza being added. And to that, I am adding half of a pizza. Okay. If the denominators are the same, then we can just add the number of pieces of pizza together. Okay. Say if you have 2 pieces of pepperoni pizza and 5 pieces of cheese pizza, and that's all you're left over with, then you could combine them into um, 3 plus 5, which is 8 pieces of pizza pieces, right? Provided that they are cut into the same fractions. However, when they are not cut into the same size, when the whole is not divided into the equal parts, same number of parts, then it's not easy to add. So in this case, what we actually need to do is we need to multiply by giant 1. We need to have the same denominator. How can 3 and 2 have the same denominator? I need to multiply the first number by 2. And if I'm multiplying the bottom number by 2, I need to multiply the top number by 2. Why? Because this just becomes my giant 1. This is my giant 1. And I'm allowed to multiply 1 to any number without changing its value. That is the reason I'm allowed to do this. And for the second number, instead of multiplying by 2 over 2, which is just going to get me 2 over 4, I need to multiply by 3 here. So this time I'm multiplying bottom number by 3. That means I need to multiply top number by 3 too. And this is how you get equivalent fraction. 1/3 is equivalent to 1 times 2 is 2, and 3 times 2 is 6. So 1/3 is equivalent to 2/6. And 1/2 is equivalent to 3/6. Okay, because 1 times 3 is 3, 2 times 3 is 6. Now that the denominators are the same, it's like adding pizza that is divided up into 6 pieces instead of a 1/3 and then a half. So then that makes it far easier to add them up. So we have 2 pieces, now we have 3 more, and that's what's represented here. We have 2 pieces of pizza that's divided into 6 pieces total and 3 pieces out of the 6 piece. So then that leaves us with 2 plus 5. 2 plus 3 is 5 out of the 6 pieces. So this tells me that we have 3, 4, 5 because we have 2 from the first pizza box and 3 more from the second pizza box. So now we have 5 out of the 6 pizza box. So the thing you need to remember is you need to have same common or same denominator. And how we do that is by multiplying by my giant 1. to do that. Okay, so let's try to do these practice problems. Okay, 5 and 3. That means we need to make this into 15 and 15. What did I multiply to get to 15? I multiply by 3. Then if I need to multiply the top by 3 as well, what did I multiply 3 to get to 15? I multiply this by 5. So then that becomes 3 times 5 is 15, 2 times 3 is 6, 1 times 5 is 5, and 3 times 5 is 15. So now that the denominators are the same, I can simply add, and that leaves me with 11 over 15. Okay, I want you to pause the video and see if you can solve these problems yourself. Okay, all right, when you see 3 and 4, what is the common denominator? That's going to be 3 times 4, which is 12. And how did I get from 3 to become 12? I multiply this number by 4. That means I need to multiply the top number by 4 as well. And how did 4 become 12? I multiply by 3. That means I need to multiply the top by 3 as well. So that becomes 2 times 4 is 8. And 1 times 3 is 3. So 8 plus 3 is 11. All two pieces out of the 12. Let's keep going. Again, 4 and 3, so we're converting into 12. So we're multiplying this by 3 and top by 3 as well, and this by 4. So that becomes 3 times 3 is 9. 5 times 4 is 20. So 9, this time 9 minus 20. Okay, 9 minus 20. We're going becoming more negative, aren't we? So 20 minus 9 is 11, but the final answer should be negative 11. So negative 11 over 12. This time 7 and 2. So we are trying to get the common denominator to be 14. So what did I multiply by? I multiply by 2, and I multiply the second number by 7 to get to 14. So negative 2 times 2 is negative 4. 1 times 7 is 7. Notice that I've just rewrote the negative sign. Make sure when you're copying things down, you do not lose anything. And then you're left with negative 4 minus 7 is negative 11 out of 14. Okay, for this problem, again, we are dealing with improper fraction. It's far better to turn it into mixed fraction into improper fractions. 1 times 3 is 3, plus 2 is going to be 5, minus 5 over 6. So how do I convert this to a common denominator? 3 and 6. Okay, what do I need? What is the smallest common denominator? It's not 3 times 6, which is 18. You could do that, but actually it's easier if you just made this into 6 minus 6. That means we're leaving the second number as it is. This is minus here. But to the first number, we're multiplying by 2 to the top and bottom. So that becomes 10 minus 5 is 5 over 6. And then this problem, 1 times 4 is 4 plus 3 is 7 plus 2. 2 times 2 is 4 plus 1 is 5. And again, when I look at 4 and 2, the smallest common denominator is not 4 times 2. I just need to multiply the second number only by 2. Be smart about it. Don't just randomly do it without thinking. Okay, so then this becomes 5 times 2 is 10 plus 7 is 17 over 4. And because it's my final answer, I do want to convert to improper fraction. How many 4s go into 17? 4 times 4 is 16, and 17 minus 16 is 1, so it's